I don't think it was.
All right, guys, so I'm on page.
It was not
Hey.
sold from it.
All right, we're going to have some soul renewing. Okay, combat depression. And hopefully this will be a really good test for you. And then again, historically, the next test I give, people really tend to do well in that. Class average is normally a mid to high A, but that'll again be up to you. So I'm just going to run through these. I'm just in this practice. We got a mixture of just pure area problems and then some of the cross-sectional volume stuff woven in there. So this one, set up the integral you'd use to find the area between the curves on that interval from -3 to 1. You may use a graphing calculator and see what you got. Now, even if you didn't have a graphing calculator, you could probably get these graphed okay. Like, what happens if you factor this thing? You pull an x out, you've got an x squared minus 4 left. So if you factor it completely, you get x plus 2, x minus 2. Well, those are your roots, 0, -2, and 2. So you end up with some cubic function that crosses 169. So it crosses it something like this. And then you have the line with the slope of a half that crosses at -1. It looks, I'm sorry, -1. It looks something like this. And I ask for the interval between -3 and 1. So you can see right here, it's going to be important for us to sketch this graph, but you can see there's -3, there's +1. And between doesn't mean bounded, does it? So don't come in here and start finding bounded regions. In between means from the interval here at -3 to +1, I want anything in between these graphs. So you can see in between is going to give me this little area over here. It's going to give me this bigger area right here. And it's going to give me this area right here. So to me, setting up your window is kind of important. If you make your window too big, too small, you're going to see more than you probably need. So I'm going to go and sketch this. I'll try the TI-84 this time. So I've got x cubed minus 4x. And then the other one is 0.5x minus 1. I'm going to intentionally set my window up from -3 to 3. So the minimum x is -3, maximum x is 1, scale is 1. I don't know anything about the y's, but I'm guessing it's going to go up and down some. So I'm going to say, just to get an idea, -5 to 5. And then take a look at this. So literally, I might want to see a little bit more of this graph down here if you want. But I know I'm doing in between from literally right here at -3, right there, to right there at +1. So I know I've got these in between areas. If it makes you feel better to make your window go down to say -10 on the y, well, you still can't see it. Window, if you want to go down to like -20, just so you see the graph better, knock yourself out, but it's really not necessary. But you can see now, right there from -3 to +1, I've got to find these areas. So do what you have to do to see these, but hopefully this will give you a pretty good idea of what your integral needs to be, right? So if I'm going to label this little value right here, which I'm going to need to find as an A, and this little value right here, which is going to be a B, what am I going to need to do this? And three intersection points, but I'm going to need 3 intervals, right? So these were not labeled f of x and g of x, so I would write them out. So I'm going to have this interval line over curve, so 1/2 x minus 1 minus the entire curve. Then I'm going to group this whole thing, dx it, right? Because what I'm really doing when I go top minus bottom, I'm finding a height. I'm giving it a little width to make a little, basically like a little Riemann rectangle. And now I'm going to sum all of these from -3 to a. And I can find my a later. In fact, I'm going to go ahead and find it, blah, blah, blah. Okay, it's negative 2.2247. But all I have to do is label a equals negative 2.2247-ish or whatever, and that's good enough. And then to save you a step, b happens to be 0.2247. So once I label a and b, I'm good. So there's my first interval. Next one, I'm going to add to this from a to b, but this time I'm going to have x cubed to start, and I'm going to subtract, and I'm going to group the parentheses around the line, big parentheses around the whole thing, dx. And then to finish this guy off, I'm going to add that from the integral from b to 1, and I'm back to line minus curve. And I'm going to put parentheses around the curve or distribute the negative, that's your call. Big parentheses around the whole top minus bottom, dx. And that's what I would be doing. And that you would get points based on this. This could be a 7-point problem. It's not like I can give you 20 of these or 30 of these and expect you to get done in time. So that might be a 6, 7, 8-point problem, but something like this, I probably am not going to have you type it in the calculator because it is so tedious. I would probably just say set it up. And I may or may not ask you to find a and b values. Sometimes I give them to you to cut down on the time, but I do want to make sure you know how to do them and then make sure you remember to label them. I want to give you a little bit of practice on that. Yeah.
What if it only gives you 2 decimals? Like on this one?
Then fix your calculator.
Okay.
So, menu, settings, you got float. Float stinks. You want to go fix 3, enter. Okay, and now
Okay,
you'll see 3.
thank you.
Yep. Anybody else have bad decimals? Okay, I always fix mine at 5 and then I round, but if you want to do 3, it kind of does it for you. The only problem with 3 sometimes, I think, is sometimes you take that 3 and you're like, I don't know, maybe it gives you the illusion that it's exact, and you write it down in there, and then you actually use those 3 instead of storing it. But I don't want that illusion, so I usually like to see more, but if you've got good discipline, you're probably good. Good on this? Okay, what about number 2? It says set up the integral you would use to find the area bounded by the curves x equals y squared, x equals 4. So yeah, that's great because I'm literally throwing up a red flag for you, right? I'm saying, oh wait, look at this, I solved for x. I mean, I solved the equation x equals in terms of y. So if I'm doing something in terms of y, it's probably going to be a right minus left. Now, do you know what these look like?
One is a vertical line, the other is a root.
Okay, so this x equals y squared is either a sideways parabola, or if you solve for y, you get plus or minus root x. So it's the top and the bottom part of a root x function. I don't care how you do it, but bottom line, it looks something like this. And then x equals 4 looks something like this. And I said bounded. So this time, we're not talking about in between anything. We're talking about completely surrounded right here. Now, I could do a top minus bottom from 0 to 4 using positive root x, negative root x. And that's totally fine if you do that. The only thing maybe you run into issues with is if the problem had said, if it was multiple choice and the answers were written in dy and you did it with dx just because you're more comfortable with dx, your answer's not going to show up. And then you're like, oh, crud, I either got to type all this stuff into my calculator, which it very well may not be a calculator problem, or work all these integrals manually to see which one matters or matches mine. But on this one, man, it's, look, you've got x equals 4, that's here on the right. You've got x equals y squared here on the left. I'm just going to say right minus left, 4 minus y squared.
From 0 to 4.
And then I got to go from bottom to top on my dy. So I'm going to plug 4 in there for x, and I get plus or minus 2. right? If you solve for the y's. So this just happens to be at -2. This just happens to be at +2. So I got to go -2 to 2. And I'm not going to tell you that every single time it's given as x equals and x equals, it has to be a dy, because they could mess with you, but it's pretty rare. I mean, in my memory of all the things I've done, that doesn't sound familiar to me. All right, what about number 3? What about it? Set up the integral used to find the volume whose base is bounded by those 3 lines. So just sketching that really quickly. I got y equals 2x. So if I scale this the same, it would look something like rise 2, run 1. The line x equals 4. Here, let me make this like this. So the line x equals 4 would make it look something like that. And then it says the x-axis. So we're talking about this region right here. Okay? So it says, all right, if I got that region, what would be the volume if I take cross sections perpendicular to the x? So perpendicular to the x means I'm going to be doing what? Top minus bottom. So perpendicular to the x, I'm going to be going top function minus bottom function. And the bottom function is what?
0.
Y equals 0. The top function is y equals 2x. So you are welcome to say 2x minus 0 for top minus bottom, but is it really necessary? No. So more than likely, if it was a multiple choice question, you're not going to see top minus bottom. Since we're doing semicircles, what would be the process for doing a semicircle?
Divide that by 2.
To divide this by 2 gives me, and the whole thing, right? That gives me the radius. Then what? Pi that squared gives me a circle. Half that on the outside gives me a semicircle. So I have the semicircle's area.
Is the inside not just x squared at that point?
All of this ends up being just x squared. I was going to show you that at the end, but yes. And that's the way you would see it on a multiple choice test. But in terms of you're setting it up, I'm trying to be kind of generic here. So that's area. What do I do to make this a volume problem? Give it a little width, and now I've got some thickness to my semicircle. And then you're going to integrate all of this from, looks like 0 to 4. And again, if this was set up what you would do, you're not going to see this. You're going to see 2x minus 0 is 2x. 2x over 2 is x. X squared. So what you're going to see is 1/2 pi x squared dx. So just make sure you know that sometimes they do simplify their stuff. But if it was not a multiple choice question, you could have this on the left or this on the here I have somebody doing it, which I'm not sure why they are so eager to do that. Like, why? You're not getting any extra points for that, for simplifying some weird way. Just let the calculator do the math if you need to. All right, now what if I'm taking perpendicular to the y-axis? So perpendicular to the y-axis means now instead of going, my slices now are going to be looking like this. Now to do that, I need to subtract this right x minus this left x, which means I have to solve this in terms of y, x in terms of y. So right here, this is the x in terms of, well, there's no y, but that's the x equals 4. This is if this is y equals 2x, then it's x equals what? Y over 2 or 1/2 y? You follow me? So right function, which is 4. So I really can use basically the same format as I did before. Okay, so right function, which is 4. By the way, all this work is for B. Left function is y over 2. And what I just did there, think about this, guys. I took this x value, this x2, and subtracted this x1. That's like me taking all of that, subtracting that, and I get this. And that's what I'm wanting to do. but I can't use these x's, so I take them and I go, oh, that's x2 and that's x1, right minus left. So I use what the x's are equal to. That's why I did this. Okay. And then, of course, dy. And then I'm going to integrate this time, not from 0 to 4, but from what? 0 to wherever these intersect. And if I plug 4 into that function, I get a y value of 8. So that must have been 8. So from 0 to 8.
Wait, what is
You
the
forgot the height.
square thing?
Oh, dang it. Yeah, that would be diameter squared.
It's a rectangle.
Rectangle thing.
Oh, yes, it's a rectangle.
Oh, I can't use this new format, sorry. So this would be base, right? Sorry about that. This is base, and because the rectangle is height is 5 times the base, I'm going base times 4 base, which is 4 base squared.
5, base times 5.
What is wrong with me? Which is 5 base squared. So base, right minus left, squared times 5, 0 to 8. I'm waiting for you to go, Mr. Hurry, you forgot that. Struggling. All right. What about this? Find the area under the curve. Oh, love this problem. I mean, I don't really love the problem, but it's a very common problem on the AP test. Just to take it to a little bit further and get people to assume the position. But if you don't, which guys, at this point, you really shouldn't be. I mean, give it a shot. I mean, if your brain freezes up on a test, well, then move on, get done, and come back to it. But it says the area under the curve of this function. Okay, how do I answer that part? Answer that part. Well, how do you find the area under the curve of that? I give you a hint. The integral of e to the 2x. Of course, dx if it's 2x. From 0 to m is equal to 10. Find m. Now, if you didn't have a calculator, just start the process. How do you integrate e to the 2x? Nice. Use substitution, because that's not a rule. E to the u is a rule, not e to the 2x. So if u is 2x, then du is 2 dx. So I can make this happen by making it 2 dx and a half. There's my u, there's my du, and I have 1/2 0 to m e to the u du, and now I can integrate. So what's the integral of e to the u? E to the u, which is 2x, but I drop down to 1/2 and put a big bar from 0 to m equals 10. Now all you have to do, now that you've integrated, is apply the first fundamental theorem, right? And the first fundamental theorem says plug the m in, which gives you 1/2 e to the 2m, plug the 0 in, which gives you 1/2 e to the 0, and set it equal to 10. Right? Now, again, might look ugly, but look, the algebra is really not that bad. What's e to the 0? 1. So I can add that 1/2. So 1/2 e to the 2m, or if you want to, multiply 2 by 2. But I'm going to add the 1/2, which gives me 10.5 or 21/2. Right? I'm going to multiply both sides by 2. Then I'm going to ln both sides to get rid of the e. And when I ln the left and the right, I get 2m equals ln of 21. And I divide it by 2. And you're done. And it required a little algebra, but it wasn't quite that bad. It just basic u substitution. This is a great multiple choice question for an AP test.
Where did you get 21 over 2?
Because this was equal to 1 right here. So I just added 1/2 to both sides. Just solving for m here. Right? Now, the answer may not look like this on the AP test. So somebody tell me what else this could look like. Give me other versions instead of ln of 21 over 2. Any other version?
Let's go with the 1/2 e to the 2m from 0 to m. I don't know. I'm just thinking.
How about
For ends,
1/2
or not.
ln of 21? Isn't that possible?
Yeah.
Okay. How about
0.5
well, yeah, ln of 20 plus 1?
ln of 21 plus 1.
How about that? Now it won't be that,
It's
but what could it be?
not
ln of the square root of 21? Do you see how you could have it some different variations?
Unfortunately.
So make sure you at least know enough algebra to go, hey, a 2 on the bottom is a half on the front. You're not going to see that, I don't think. You're going to see this, or you're going to see that. But just make you know, wait a minute, 2 on the front is a half. A half could be sworn up. You're not going to see it written like this, I don't see. But a 1/2 power is the square root.
It's true about one.
Those are probably the two versions that you might see. Yes?
Did you ever see it as like ln of 7 plus ln of 2?
I would be shocked if you saw it. It would be true, but I would be shocked if you saw that because there's no real reason. They're not Vestavia. I mean, Vestavia, they're going to, at a math term, they're going to try to find a way to totally ug up their answers. But no, what they usually do is there might be a different method of solving that would lead them to here. I mean, there might have been like, potentially, they could have done this. Like, potentially, I could have said, hey, e to the 2m is e to the m squared. So I could have square rooted to get to here, and then just ln both sides. Are you following me? So if there was a different way to solve it that they maybe used, then yeah, that answer might be there. But I don't know of any on the planet that would have left you with ln 3 plus ln 7. I don't see them doing anything like that. Never. That does not smell familiar. It smells like Vestavia, which is a wretched scent.
Correct.
All right, look at number 5. Set up the expression used to find the volume of the solid whose base is the area between those graphs. So the base is the area between the graphs on that interval, and cross sections taken perpendicular to the x are. Let's try the first one. So I've got F and G. I've got a calculator, so let's just go ahead and graph these and figure out what, I tell you what, I know what they look like. Here is your F function. It looks something like this. And then here is your G function. It looks something like this. And just to save us the trouble of typing it in, and it says between the graph. So I'm not looking for any bounded region. There isn't a bounded region. I'm looking for,
Well, I mean, the boundary is set up by the -2.
right, but I don't, that would be in between them. And now if I said bounded, I would have to say between this, the vertical line, x equals -2, and the vertical line, x equals 2. They're going to bound it for you. They're going to give you boundaries if they're going to do that. Otherwise, they're saying in between. So -2 is somewhere here, +2 is somewhere there. So I'm looking for this region right here. So if I'm doing perpendicular to the x, that would be a what? Top minus the bottom, and height 4 times the base. So the base times 4 times the base gives me 4 base squared. And how do I find that base again? Top minus bottom, which would be F minus G. So it makes it pretty easy for you because you can use, if I just say set it up, which is all I did, all I got to say is F of x minus G of x, that's top minus bottom. Square that thing and multiply by 4. Right triangle. Man, I'm struggling. I need to read. So right triangles would be 1/2 base times height. So 1/2 4b squared, which really ends up being what? 2b squared. I'm using my formula. So 2 base squared is all I end up with. And I want to integrate from -2 to 2. And that's all I need to see there.
Yes.
Do you need the DX?
Yes.
Yes, and why is my key bad? If you look at the key on this, it's bad. I'm struggling on all fronts. 1/2 base times height. So 2. I don't know if this is an I now or not. All I did was I ignored the 4 on my key, but anyway. The other one is correct, okay. And then on the next one, still perpendicular to the x-axis, but I have a rectangle whose height is 5 times the base. So base times 5 base, 5b squared. So what changes on this? What changes for B? What changes on this thing? The 2 turns to a 5. That's it. If I said, just for fun here, if I said semicircle, what changes?
Just the inside bits.
Inside.
And a little bit of the outside bits. By over to the outside.
So I gotta make that a radius if it was semicircle, right? And then I gotta go 1/2 pi r squared. And sometimes they'll say circle also. So they won't say that there's a base, they'll say a circle, but you have a semicircle on one side, semicircle on the other, and you just get rid of the half. What if I said this? What if I said the rectangle whose height
It's a circle.
is given by h of x equals natural log of 2x minus 1 to the 4th.
Just move that outside the.
Then what do I do? They do this occasionally. They'll give you the height in terms of another function. Well, what am I going to do? I still got to find the base, right? So the base is still f minus g. So there's your base. And you're going to multiply by the h of x. That's your height. So this is technically my area right here, right?
DX.
Give it a little,
Move out of 1/2.
give it a little width. Make it volume. And then again, integrate from -2 to 2. This is not uncommon for them to say something like h of x, which is not shown on the curve or something like that. And then they'll, whatever. They gave one function earlier. Tell you what, let's just look at it.
Let's just do it.
I was gonna revisit it next chapter, but why not? You don't have a copy of this, but this was 2000, maybe 18. I was looking at it this morning. Let's check it out. Let's see. Hold on.
How do you know?
He's an avid follower. Buddy.
Good show.
It is a good show. I grew up watching it like the
My
reruns.
6th grade teacher used to play it in class.
We watched this video production.
You took a video production.
Yeah, I did.
Wow.
Yeah, I did. I'm looking for a big funnel.
A big funnel.
You can like make one out of the not today sign.
You could. But then everybody would have to turn in their homework every day.
Oh, we can't have that.
We couldn't do that to the other kids.
Ah,
Oh, there it is.
now I don't know what. Hey, this messed people up because they don't know what they're actually doing. They're memorizing stuff. And I remember when I first glanced at it, I went, "Oh, great!" Like I was so used to having these nice, cushy volume questions, and they threw this one at us. Okay, and this is just a few years back, and it says, "Find the volume of the funnel."
Right.
Alright.
Yes, it's just
Yeah.
it's just a circular.
No. Hey, what did they give me? They gave me the radius. What do I need to find a volume?
Diameter.
Like if you think about it, if I'm looking at this, what are my cross sections?
Circle.
Circles. And I know the radius.
Easy.
So how do I find the area of each cross section?
Pi r squared.
Pi
Or you
radius.
probably move the pi outside.
1/20th 3 plus h squared. That's pi radius squared.
Give it a little volume.
That's the circle, right? They gave me the radius. I didn't have to divide by 2. People that memorized totally freaked out and skipped this. And I was like, how did you skip that? It's just, they're handing it to you, right? They gave you the radius, pi radius squared. That gives me this. And all I got to do now is integrate it from what?
A to B.
From what?
0 to 10.
0 to 10, because that's what h is. H is defined, a height goes from 0 to 10. So I give it a little dh just because that's the variable I know. Integrate, well, I'll probably put it here. Integrate from 0 to 10. Are y'all seeing that?
Oh, we're seeing.
But people, like, this is a 3 or 4 point question. And people just skipped it because they're like, oh.
Right, so for the
Is that-
height,
But you didn't have to find any right minus left. Yeah.
Average height into that?
Isn't that a cylinder?
Yeah, like what if you don't average height into the.
That's not a cylinder because it's fluted. Cylinders.
Yeah, but like where I'm not saying you're wrong. Where like on there is it fluted? Like I'm confused as to how it's like decreasing.
Well, look, this is R, right? So this is R. R changes. It goes from very little to very big
Right.
as H changes. So like, think about it. When H is really small down here at the bottom, you've got 3/20ths. 3/20ths is pretty small, like 1/7 of a unit, right?
Mhm.
When H is really big up here at 10, you have 103/20ths.
Oh, gotcha.
So that's like over 5, right? So you're going from really tiny to really big, and you're finding all of those. But if you all of those volumes, right? Because this is a bunch of pi r squareds, all given a little width.
Gotcha.
So from very little disks to very big disks.
Okay, so the 1/3 or whatever you use with like normal volume doesn't matter.
Yeah, because that you're thinking of cone,
Or yeah.
but this is a cylinder. We've never had a formula for cylinder. Oh, and by the way, your formula for a cone is done with calculus. Nobody taught you that in 9th grade when they gave you the cone formula, right? Just because, or the sphere formula. Those are calculus. We're going to do that next, starting on Monday. I'm going to show you I'll show you where the sphere formula comes from. It's calculus.
that's so.
But it's kind of like physics 1. When you don't know calculus, you just get dished a bunch of formulas, right?
Yeah.
And then you learn calculus and you're like, the derivative gives me velocity from position. So the calculus really does a lot with what we use, but try teaching that to a 9th grader, man. Can't even keep their fly zipped or whatever. I mean, and I was one, so I'm not like, But anyway, are y'all with me? But don't make these too hard, right? Trust the math. If you understand what you're doing when you're actually finding these areas, that you're finding a little area, giving a little width, and then pulling that area as it evolves and changes over that interval, which this one's clearly doing, right? Dude, it makes sense. And next chapter is really going to make sense because we're going to be actually taking a function right here, which we didn't have. We just had an R function. I'm going to give you like this function and say, hey, rotate it about that line. And you're going to do that. But again, as long as I can take that and find the radius, it's just like doing this. If I can find a radius function, pi r squared, there's your disk. Swing it up. But anyway, I like this question. I didn't love this volume question, but I look at A. Find the average value of the radius. How do you find average value? Shockingly, the most missed question.
It's the
Big after B minus big after that, it's that, something like that.
How do you find average value of anything?
Add it up and divide by 2.
What? The integral of a to b of whatever function you're talking about over b minus a.
Oh, was that last time?
So in this case, since I'm going from 0 to 10, guys, average anything. I think what kills people is they're so used to finding average, like mean, median, mode kind of average, that they kind of start shaking and freak out. Average anything is this formula. Average blah, A to B, you want to say over and over and over and over. So simple. You don't even have to think about it. I love those. I kind of get a little giddy. Find the average, my brain shuts off. I start writing formula. Plug it in. Anyway, and then the last part actually had a related rates thing, but I'm going to cover that later. What about let's jump to 2017 AB number 1C. So 2017, I don't know if you have that.
I don't think we do.
Do you?
I don't think we can go to the here.
We got 2017 Part A.
2017
Oh, we do
number
have it.
1C.
It's the last page.
Okay, so 2017 number 1 C. Okay, look at this. It gives you a, it says a tank has a height of 10 feet. Well, here's your chart, and you can see the height going from 0 to 10. It says the area of the horizontal cross section. Horizontal cross section, right? So if I have this tank that's up here, and I don't know what it looks like, it could be doing all kinds of weird stuff. But the horizontal cross section, the area of that is given by the function A, where A is measured in square feet. I don't know what that function is, but I do have a couple of values on that function, don't I?
Correct.
Okay? So the first thing says use a left-Riemann sum to approximate the volume. Well, let's do it. It's just a volume question. If I have area, what can I do to find volume?
Integrate it.
So area times height gives me a volume. We've been doing that with the DH, right? So if this gives me the area, if I'm doing a left Riemann sum, what are my intervals? 2, 3, and 5. And the left uses that, right? So I'm basically taking area times height. So that's like square feet times feet. What's that give me? Feet cubed. So 50.3 times 2, 14.4 times 3, 6.5 times 5. 2 points when you add it up correctly.
Easy.
Does the approximation overestimate or underestimate the volume?
Under.
Left.
Think about it. What's happening to these area values?
If it's decreasing the.
Yeah, from 0 to 10, which I have what? 0, 3, 5, 10. And you can see I'm at 50.3, 14.4, 6.5, and 2.9. Now, I don't know what's going in between there. I don't. It could be going up, down. Who knows what's going in between? I can't assume it's a nice curve, but it really doesn't matter because the left sum is going to do what? Now, to me, that looks like it's what? Overestimated. And how do I know that? What does it say right here? It's so key. A is continuous and decreases. So all you would have to say is it overestimates. Why? Because you can just say this. Don't draw pictures. Do you know that the AP reader is not allowed? You're given a box, and you have to write your answer in the box. Well, the picture's always outside the box. So if you go up there and draw pictures like this and go, look, it always overestimates. They're not allowed to look at
Can you
that.
draw your own picture in the box?
You might be able to draw your own picture, but you know what's a whole lot better? Just saying left Riemann sums over approximate decreasing functions. Done. They're literally, when I graded your papers, I was like, I looked for the word overestimate or too much or whatever. And then I just looked for increasing, or decreasing. When I saw it, check the box, moved on. Literally, all that blah, blah, blah. You could have told me off, made fun of my mother. I didn't even look for it. I'm just literally looking for the word increasing and decreasing. And I guarantee you the AP reader who has to go through 1,000 of these a day is doing the exact same thing. So literally say, left Riemann sums over approximate decreasing functions. Move on. And then right here, the area in square feet of the horizontal cross section at any height. is modeled by this. So again, that is the what? The area of the cross section? Dude, well then how do I find the volume? If the function is the area, then all I got to do is take that and do what? This is area. Before that,
Multiply it by height.
give it a little width, right? And the width, it's in terms of h, so give it a little width. Now it's a little volume chunk, right? And then integrate from 0 to 10. Like, tons of kids miss this. Because they're like, man, I got to do top minus bottom. How do I do top minus bottom? I'm freaking out.
Wait, do you not need to multiply it by height or?
I did. That's the DH, the little change in height. So think about it. I have this tank, right? I don't know what the tank looks like. It said, hey, the area of the cross section is always given by f of h.
Do we know what shape the area is or just a random area?
Yeah, it's the shape of 50.3 over e to the 0.2 h plus h, which I have no idea what that looks like. I'm guessing it kind of shrinks a little bit because of this right here. Shrinking is probably exponential since there's an e on the bottom, right? But that's all I know. But again, all I know is that area is f. So if I give it a little width, right, now I've got actual area here. So that's the DH. And then I just stack them up, 0 to 10. You seeing this?
So it's not like those like basic geometry ones where you have to actually do things to the function. You just
Well, I kind of did, but remember, all of this was just to find area, right? So AP, and listen, in the last 4 years, like literally for 20 years, they gave us these routine questions, same old, same old, same old. And in the last 4, they've given the fluted one, right? They've given this one. They've not had a volume question on there at all. And when they didn't have one at all, it did show up more on the multiple choice. I will say that. And so you still got some points out of it. Volume and area just showed up in a different place. But remember, all of these are for area. So if they give you area, you're done.
Easy.
Who cares about all this? They gave it to you, right? So anyway, those are, and then part D was I think another related little rates thing. But they're starting to change up those volume problems because people like me have brainwashed my students into doing them, and they just become like, oh, I can do these in my sleep. So they're like, all right, we'll throw them a curveball, see who can think and who's just memorized. You probably haven't seen this movie because it's super old, but there's a movie called Stand and Deliver. True story about this guy in inner city Compton, LA. Have you seen it? Okay. It's a good movie, but it's getting kind of dated now. But it's a true story about a calculus teacher who moved into this district that was poor and everybody was in gangs. It was just, and he was determined to teach these kids calculus, which I'm not exactly sure. I mean, like it was like they literally showed up in the calculus class not even knowing how to do pre-calc. And he's like, all right, we got work to do. Y'all gonna have to start coming here on Saturdays. And the kids bought in. And the scores were so good that they voided his scores and said that you must be cheating. But like one of the knocks on this guy was his kids didn't know how to think sometimes. They were just memorizing stuff because he just, instead of spending 180 days with them like I do with you guys, he was like every other Saturday or every Saturday as well for 2 and 3 hours. So he was sneaking in like basically 180 extra days of work. But these kids, man, I mean, think these are poor kids from inner city schools that were making 5s on their AP test. They're getting scholarships to go places. So he really changed a lot of that little community while he was doing it. But I forget his name.
is it based on a true story?
Yeah. I'm trying. The only name I can remember is the actor. His name was Edward James Olmos, I think, but I forget his. He normally plays like a crime lord, but he's an old guy now. He's got a really like scarred face, you know. He's kind of. Yeah. No, that's Chandler. But anyway, it's worth watching. When our year used to end, yes.
Well, it wasn't about that.
About this question?
Hey,
Yeah,
the math can
For C, it says like indicate units of measure, so how would it be like that one?
Feet cube.
So like just next to it?
Yeah, I should have said that. I didn't, again, I'm struggling today to read. But yeah, anytime it says units of measure and it's volume, it's something cubed. So whether it's in feet or meters or whatever.
So just like write it next to it.
Yeah, just FT cubed is what I would write. Yeah, and you really need to get in a good habit of that. A couple of y'all came up to my test and were like, how do I show feet traveled? You didn't give me a unit. Well, if they don't give you a unit, then don't worry about it. But if they ever give you a unit, put the unit. Because sometimes they won't indicate units of measure. They won't say it, but they'll count off if you don't do it. Sometimes they will say it and then count off if you don't do it. So anytime you're given a unit, put a unit. What do we got, 4 minutes? I don't know if we have much time.
Boy, finish the story.
Oh, yeah.
I don't know that
We were talking about Scarface, I think.
so I didn't get to one question. If you want to go look at that, the key's out there. And if you're wondering is your test going to be just filled up with a bunch of stranger problems like the fluted one? No, it's pretty basic. It's pretty basic. So if you know everything we've talked about, you know how to use your calculator, you should be in good shape. Yeah, George said something. I did not do a tangent line. A lot of you are struggling with that. Make sure you go and review how to find a tangent line and then use that for one of your curves.
I didn't know, so they were building up, they were refurbishing the house. Part of the refurbishing process was filling it with sand, not filling it with sand, building like a straight wall.
See, you guys forgot all about your essay. Feel better already, don't you?
I didn't think he was their house. So I was at him, and I started digging through sand. And then they teleported.
Y'all, we wanna play
bingo. Because I thought.
Can we play
That's what I thought.
I thought this was real at first. I thought this was real life until I was
Yeah, we did that last.
Oh my God.